Let's go over another fairly straightforward problem from Project Euler, problem number 79, passcode derivation. So in this problem, let's see what they have given. A common security method used for online banking is to ask the user for 3 random characters from a passcode. For example, if the passcode was 531278, they may ask for the second, third, and fifth characters. So bank asks the user from a secret password, which is this 531278, the second, third, and the fifth digits. So the expected reply would be 317, which is the second, third, and the fifth digit respectively. After that, they have provided us with a text file keylog.txt which contains 50 successful login attempts. So I have mentioned them on the right. So they are one line separated digits, 3 digits in each line, which are the successful login attempts. That means each of these 3 digits does correspond to some valid password. So there is some passcode that we need to crack, which contains the 1 to 9 digits at some positions. And next they have given that the 3 characters are always asked for in order. That means for let's say for example this second attempt, for this 6 comes first, then 8, then 0. That means the order in which the digits are given is consistent in the passcode as well. So this is the problem description. Next they are asking us to determine the shortest possible secret passcode of unknown length. So we are asked to determine the passcode from this successful login attempts which are given on the right, which is about 50 login attempts. So let's look at some of the observation. You may pause the video and think on your own. So let's denote the number that we want to find by n, which contains k digits, which is still not fixed yet. So for this number, we are given that, so let's say this n represents our passcode that we want to crack. For this we are given 50 triplets, so I am going to denote the numbers that are given in the file as triplets of the form d1, d2, and d3. So for these, since they are given in sequential order, that means we can say that they are present in the passcode n in the positions I, j, and k, such that they are incremental positions. So I comes first, then j, then k. And if a valid attempt is made, then there are some positions I, j, k, such that d1 is present at ith position, d2 at jth, and d3 at kth. And from this we can observe that d1, d2, and d3 is a subsequence in n. So for all the triplets, the main observation that needs to be found is that all the triplets are a subsequence of some passcode of some fixed length. Let's look at another one. So for the same description of the passcode with k digits, we can say that all the unique digits present in the triplets must be present in n, since they are present at some positions. So we can say that n is made up of all the unique digits in all the given triplets. So this is another observation, and from this we can derive that n could be any permutation of such unique digits. So there could be, if a number contains 5 unique digits, then we can iterate over all the possible choices of n by going over all the permutations of those unique 5 digits. So these two observations lead us to this solution. So let's see what it does. So first of all, we need to say that n is a set of all the unique digits from all the triplets. So let's say we arrive at 6 unique digits from all the triplets, then our n is a set of those 6 unique digits, and after that we need to go over all the permutation of this set and find the smallest number for which this condition is satisfied. which is that since it is a valid login attempt, that means all the given triplet must be a subsequence of that permutation, particular permutation. So this is the main idea, which is a simply straightforward naive approach. We will also go over a little better approach using graph theory in the next part. So let's see how to implement this one first. So this is the C++ implementation for this. I have used this subsequence function to check whether T is a subsequence of S. This is a fairly straightforward greedy approach. At each position, we start off by searching the first character of T. If it is found, we need to search for the next character, and it is always better to find the position in S which is earliest, and we go over, if we reach the last index of T, that means we have found out all the characters, and that will determine that T is a subsequence of S. So this is the function for that. Next, I have used a vector of string which is going to store all the 50 given triplets. So we are iterating over this. So you may send the input using a standard input or even read a file from here. So I am going to store all the 50 strings in this vector. After that, I am going to create a new vector which present of I denotes that ith digit is present. So if 9 is present in any of the one of the triplets, that means this present of 9 will be true. So we are basically doing that conversion here. We are going all the triplets for all the characters in all the triplets. We are going to mark the digit that is present in that triplet as true, and once it is processed, after that we are going to construct a string S which denotes the set that we were talking about earlier. So we are going to check for all the digits from 0 to 9. We are going to see if it is present in any of the triplets. That means we need to consider it in our set, and we are going to simply push back. And I've also added a log that I is present in our final answer. And since this is performed sequentially, X will be stored in sorted order. So we can simply apply permutations on it. So we are going to go over all the permutations of X, and we need to validate some of the conditions. So let's see what the conditions are. Since want consists of all the given triplets, so we are triplets. I'm checking that all the triplets must be a subsequence of the permutation X. Hence, for this loop is going to run for every permutation of X. This next permutation is mutating the string in place, so we don't need to perform any permutations on it. This is provided using C++ STL. So for every given triplet, we are going to check it if it is a subsequence of X. If all the triplets follow that, that means we have found an answer. And since this X consists of string, and we are going over all the next permutation, that means this will go lexicographically. And since we also want to find out the smallest possible number, so that means we are also going to arrive at the solution for which the number is smallest first. Hence it is optimal to simply return or break the condition whenever we found a valid answer from here. So yeah, that's it about the C++ implementation. Now let's go over a better approach using graph theory. So you can model the problem as a graph. So each of these is going to represent a three node path in the graph. So 3 to 1 there is an edge, 1 to 9 there is an edge, 6 to 8 there is an edge, 8 to 0 there is an edge, which is a directed edge. And this is how the given passcode attempts are going to look like. So any given 3 digits can be a 3 node path in the graph, which is D1 to D2, which is a one directed path. directed edge and another directed edge from D2 to D3, and this graph consists of 10 nodes. There will be 10 digits from 0 to 9, and once we construct this graph based on the triplets that are given to us, we will see what we can do next. Then after creating those edges in the graph, we are going to find out how the presentation is going to look like. So let's say we have 10 nodes, and for each of the triplets, so green colored path represent one triplet and the blue one the other. After you have added all of them, we are going to arrive at some structured representation of the number, and we need to find the smallest number in this, which consists of all the nodes that are given. So obviously it is an application of topological sort. So in this graph of 10 nodes, you need to find out the topological sorts, which will be a fairly small number as compared to the number of permutations that we were finding in here. Since we already know which digit can go from which location to other, so in this approach the time complexity will be fairly reduced, hence it might be a faster and more optimal approach. So if you go over all the possible paths from some starting node to some ending node, and we are going to say that this path is satisfying all the triplets, and you need to choose the smallest number from all of those. So this backtracking approach, or even you can do it using BFS. Yeah, that's it about this. I am leaving the implementation for the optimized approach to you, and do let me know what you think about this. If you have any doubts, do let me know in the comment section. Thank you.